Welcome to Xamarin University. This session is XTC103, Deploying to Test Cloud. Please be sure to download the class materials from the Xamarin University website. This course builds on XTC102, where we learned how to create acceptance tests with Xamarin UI Test. In that class, we use the simulator for all of the testing. But as with any sort of testing, you eventually want to run your tests on real devices to see how it performs. So in this class, we will look at installing our UI tests onto real devices and the requirements for that. Finally, we'll demonstrate how we can run our existing acceptance tests on a very large number of devices by deploying our tests up to Xamarin Test Cloud. And this becomes extremely important considering the large number of devices on the market. Now, while the simulators and the emulators are nice, there are many times when you'll need to test the applications on the devices themselves. The devices have features that the simulators simply don't have. There are sensors, access to services like Google Play or HealthKit, cellular access, and a whole other range of services. There are some specific changes that we'll make to our projects so that we can deploy and run our tests on a real device. In this part, we'll examine the platform-specific changes that need to be made to your Android and iOS projects. Now, up to this point, you've likely been running on simulators and emulators. However, you can do your own local testing on devices as well. You can write your tests in Calabash, which we'll cover in XTC201, or in Xamarin UI Test, which we cover in XTC102. To do that, you have to tweak a couple of the app-specific settings on each platform. And these settings will need to be adjusted no matter which testing framework you want to use. Let's turn our attention to the platform-specific changes that we need to make, starting with Android. When you run your tests on an Android device, you'll need to tweak your build settings. First, you'll need to include the internet permission. UI Test is going to make a quick call to Test Cloud to verify the API key when the tests start. It will cache the results off and keep them for a month. So once you validate the key once, you can then run the tests without checking with Test Cloud for about 7 days after that. The second thing you'll need to change is the supported application binary interfaces, or ABIs. If you've taken the publishing class, then you're familiar with this setting, which affects the architectures you can deploy to. This setting is located on the Advanced tab of the Android Build tab in the Android Project Properties. If you go to that tab and find the ABI section is disabled, it's because you're using the shared mono runtime. And this feature is on the General tab, and it must be disabled in order to run UI tests on the device. The shared runtime is enabled by default on debug builds, so make sure to turn that off. Then, you must select the ABIs to include. Most devices will require some variation of the ARM processor, so selecting all the ARM variations is generally the right choice. If you plan to run the tests on an emulator, like the Xamarin Android player, then make sure to include the x86 runtime as well. The API key and the build settings changes are all that's required for Android, and running Xamarin UI tests on an Android device is identical to running the tests in an emulator. You can decide where to run your tests right from Xamarin Studio. The device or emulator to use is defaulted to your current build configuration. By changing the selection in the toolbar, you can then deploy to a different emulator or device. You can also use the unit test pad to change the target only if you've associated the application in the IDE. Just right-click on the app node and get a pop-up where you can select the device or the emulator. Then you just build and run the UI tests, just like you did with the emulators. However, be aware that the device you run the tests on must be unlocked before the IDE will start the tests. Now, if you have an Android device connected to your computer and it's properly configured, then UI Test will attempt to deploy the application to the device and run the tests on it. If you have more than one device attached though, or there's an emulator running, then you'll need to provide the device serial identifier using the device serial method on your configure app, as you can see here in this code. You can obtain a list of the running devices and emulators using the Android Debug Bridge, or the ADB application. In order to run the application on the device, you will also need to provide the device serial ID as well as the API key method in order to connect to the application. Now that we've seen the Android step, let's look at iOS. It has many of the same requirements. First, we want to make sure to use a debug build. Otherwise, a bunch of the code gets stripped out by the linker and the Calabash server will be disabled. Next, you'll want to include all the processor types when you build your application. Since it will now be running on a real device, we'll be compiling it to ARM code with the AOT compiler. One final note, iOS applications are always built on the Mac, even if you're using Visual Studio as your development environment. Due to the way the app has to be packaged and built on the Mac, we don't currently have support for submitting iOS applications to Test Cloud from Windows. That means you'll need to switch to your Mac host and then build and submit the application from there with Xamarin Studio. Next, if your device is running iOS 8 or later, which it likely is at this point, Apple now turns off UI automation by default for non-simulated devices, and you must enable it in the developer settings. If you reset the device or update iOS on it, then you will likely have to repeat this step, as Apple will turn it back off when they refresh the operating system. Now, like Android, running UI tests on an iOS device is very similar to using the simulator. Instead of providing the path to the application bundle, you'll need to use the installed app configuration method to specify the bundle identifier and provide the device identifier for the iOS device. This assumes that the application has already been installed in debug mode on the device. If you're using Xamarin Studio to run your tests from within the IDE, then it will use the device you've selected, either in the build configuration or from the unit test pad. If you're running the tests from the command line using the nunit-console, then you'll need to identify the device in the test itself, and there are two approaches you can use. The best approach is to use the unique device identifier. You can see it highlighted here. Each device and simulator has a unique identifier assigned to it. Devices that are plugged in are assigned the identifier when you plug them in, so be aware that it might change if you disconnect and reconnect the device. You can get this identifier in one of two ways. The easiest way is to use a command line prompt and run the instruments command. As you can see here on the slide, this dumps out all your connected devices and configured simulators and shows you all the assigned device IDs. Copy the value in between the brackets and paste it into your test code to target that specific device. Now, if you want to avoid the command line, then you can use the devices window in Xcode as well. This will provide the same value, but in a GUI. A second way to identify a device is through its IP address. And this, of course, assumes that the device is on the same Wi-Fi network as the computer that's running the tests. You can get the IP address on your device through the settings Wi-Fi information. Then, put this IP address into the test configuration using the device IP configure method. Both approaches work, but the device identifier approach, where the device is physically plugged into the machine, that tends to be a bit more reliable, so you should prefer that when you can. To actually run the tests, we can use either IDE. Xamarin Studio can launch the app right on the device, or we can use the command line and run our unit test that way. You can download the full nunit package from nunit.org. The Windows zip file can be installed on Mac and run with Mono. The nice thing about running from the command line is you see each step as it's performed logged to the console. This is also the approach that you might take for automated testing from a build server. And currently, Visual Studio does not support running the tests directly on a device from the IDE. You'll need to switch to Xamarin Studio or use the command line approach. And once you start adding specific configuration to target a device, you'll override the unit test pad settings from Xamarin Studio. However, if you want to be able to take the tests and run them from the command line or from Visual Studio with a specific app target, but also run the tests from Xamarin Studio and change the targets in the pad, you can add the PreferIdeSettings method into the configuration chain. This will ensure that the IDE settings override anything set directly. So you can use the same config for both the IDE as well as the command line execution. Now we're going to take a flash quiz. The flash quiz is meant to reinforce the material that we've covered so far. I'll read the questions on the screen, and you should answer to yourself as we go through them. Question 1. To deploy UI tests to a physical device, I will need what? Is it A Test Cloud account and password, B, a Test Cloud certificate, C, a release key store, or D, none of the above? Well, the answer is D, none of the above. We can deploy our UI test directly to our physical device without any of that. Question 2. What platforms and IDEs can I use to run iOS UI tests? This could be more than one, so select all that apply. So A, Visual Studio and Windows, B, Visual Studio Code and Mac, C, Xamarin Studio and Windows, or D, Xamarin Studio and Mac. Well, for our iOS tests, we are limited right now to Xamarin Studio and the Mac to be able to run those. And question 3. If Steve runs a UI test from the Xamarin Studio IDE and does not select a specific device to run it on, then the test will run on what? Is it A, the first simulator or emulator, B, the active build configuration target, or C, none, Steve will get an error? Well, that's going to pick up the active build configuration target, and you can set that right in your IDE dropdown. Now we're going to work on an individual exercise. The primary goal of the exercise will be to take an existing set of UI tests and deploy them to a local device connected to your development system. Open the Start Here.html from your downloaded materials. Click on Exercise 1. Please read through the instructions carefully. This exercise is meant to take about 10 minutes, but you can take as long as you need during the video. Now, please pause this video, work on Exercise 1, and continue the video when you're done. Now we've looked at how to take our UI tests and deploy and execute them on real devices to make sure our applications work properly on the physical hardware. And while that's exceptionally powerful in a local environment with your own personal devices, the true power of UI testing lies in the fact that you can take a working local test case and push it to Xamarin Test Cloud with no modifications, scaling out your testing efforts across a pool of more than 1,000 real, non-jailbroken Android and iOS devices in a cloud environment built for performance and stability. In this section, we'll talk about the end-to-end process of running our tests on the Test Cloud servers. This includes what we need to do to get our apps ready to run in the Test Cloud environment, how to appropriately select devices, and how to upload tests to the system. We'll then finish by examining the results of all the test runs on all the devices in the Test Cloud portal. So Xamarin Test Cloud is a cloud-based mobile acceptance testing service which you can use to deploy your apps and UI tests to hundreds of physical devices. Once the test is run, you can access the Test Cloud web portal to see the results. You can see the link down at the bottom of the screen. The portal allows you to configure your applications, tests, and the people who can execute and view the results. To access the portal, you'll need to log in or create an account on Test Cloud. The first step in using Test Cloud is to log into the portal. This uses the same user ID and password as your Xamarin University account or your Xamarin website account. You can register a new account if you're creating a new organization, independent of that account that you use for Xamarin University. You'll then be prompted to accept the license agreement. And Test Cloud accounts are set up with different privilege levels. When you log into a new account on Test Cloud, you'll be considered the administrator of that organization. You can have multiple administrators for the organization and multiple teams with users. So your company might have a Test Cloud account, in which case you might just be a user on a specific team. Each team that's defined in the organization is given a unique API key, which is used to identify the team. You either must supply this key with the tests when you upload to Test Cloud, or use the IDE, which is going to ask you for your login credentials, and it will obtain the key for you. Now, Test Cloud has a bank of iOS and Android devices that you can test your apps on without having to pay for and maintain all of these devices yourself. All of your tests are going to run in parallel on whichever devices you select. Now, after each test is complete, the devices are reset to their factory configurations to ensure that there's no testing artifacts that will affect other apps or other tests. You can examine the results of all your tests in this beautiful web interface, which lets you explore each test. And you have access to screenshots, memory, and CPU performance information on the devices as well. You can even see a recorded video of the test execution itself if you're testing on Android 4.0 or above. The Test Cloud team is constantly adding and provisioning new devices. You can get an update on the total device count and the device breakdown just by going to http://testcloud.xamarin.com/devices. Now there are multiple ways to submit tests to Test Cloud. The easiest is the IDE integration, which allows you to simply right-click on your test project in the IDE and choose Run in Test Cloud. There are also command line versions that you can run on either Mac or Windows. However, if you're interested in a more consistent testing approach, you can integrate Test Cloud into your continuous integration process as well. If you're using a local continuous integration server, TeamCity, Team Foundation Server, and Jenkins can all be configured to execute Test Cloud's command line submission. For a cloud-based solution, Visual Studio Online recently announced the ability to build Xamarin solutions and can submit to Test Cloud as well. So you can and should make acceptance testing an important part of your whole continuous integration pipeline. Now, when we start deploying our tests to Test Cloud, we have to do all the same steps that we did with the local devices. You can either publish the app to your local file system, just like you would if you were building an app to upload to a store, and then submit the app and the test to Test Cloud from the command line, or you can use the IDE to run the tests on Test Cloud directly. In this case, Xamarin Studio and Visual Studio will build and upload your app and tests automatically and then execute them for you. One thing to note here though, you should go ahead and create a release build for your Android app, but for iOS, continue to use the debug build because the Calabash integration is turned off when you create a release build. Now, the Test Cloud servers are versioned along with the NuGet components that you install in your application. These are generally backwards compatible, but you should always update just to make sure before you submit your app. This affects two components: the Xamarin UI test, which is added to your UI test project, and also the Xamarin Test Agent, which is added to the iOS projects. Make sure all of that is up to date before you submit to Test Cloud. Your Test Cloud account will have a set number of hours associated with it, which come from several different places. Each time you run a test, the total runtime is charged to the bucket of hours associated to the account. If you have a Test Cloud license, you'll pay for those hours. Subscribers with a valid Xamarin license, though, get 60 minutes per month, which renews each month, and Xamarin University students get 20 free hours, which renews each time you renew your subscription. 25 free hours, which renews every time you renew your subscription. Currently, this is going to use the Xamarin subscriber minutes first each month, the 60 minutes, and then it's going to dip into the 25 hours if you run out. You can also use the command line to submit an app bundle or APK that you have stored locally on your machine. This is done with the Test Cloud tool. This is included in the UI test NuGet package. So you'll open a terminal window or command prompt, change your current directory to be the solution folder for your UI tests, wherever the solution is defined. On the Mac, you're going to use Mono to run the Test Cloud tool. And you have to include the APK or bundle, the API key for the team, the device hash to use on Test Cloud, your email address account, and the locale to run on. Now, if you look at this command line and wonder how you're going to remember all this, well, it turns out that the Test Cloud portal will help you out here. To easily generate the command line and set up our test for command line execution, we can create a test run. This is done in the Test Cloud portal. Again, that's at testcloud.xamarin.com. Once you're logged in, click the New Test Run button to configure a new test run, either for an app you've already tested or for a new application that you're just starting. And this will walk you through a wizard on the website. One of the most important steps is to select the set of devices you want to run the tests on. In the case of Android, for example, even an app that supports Android 2.3 applications and above will have roughly 6,500 devices that can be supported. So, which devices should you select? Well, ideally you want to select the core Android devices that are available on the market. The list on the right-hand side outlines the core devices by market share. Again, ideally you want to target the main devices when you're selecting which ones to run on Test Cloud. Once you've selected the devices, you're then prompted for some other options. It's useful to organize your test runs into categories. These are called test series. These are user-created. The system creates a single one called master, but you can create as many as you like to track versions of your app, maybe special builds, things like that. You can also specify the language you want to have configured on the device for locale testing. And you can get the system to run your tests or test fixtures in parallel to decrease the time it takes to run the test. By default, the tests are all run in sequence. So for example, when you submit a test to run on 10 unique devices, those tests already happen at the same time across all those devices. But the individual tests run one after the other on each device. Changing the parallel setting alters this behavior. Test Cloud has several copies of the same devices, so it can split a test suite into chunks and execute the chunks in parallel on equivalent devices. In the end, the results are all stitched together to form a test result as if the test had been executed serially on a single device, and your test will come back much faster. For large test suites, this can make a huge difference. As an example, the Xamarin Forms team uses Test Cloud to verify each release. When we run that suite with Xamarin Test Cloud's default serial configuration, the suite takes around 2.5 hours to execute. When run with test parallelization turned on, the execution time drops to just 12 minutes. Once you finish the wizard, it will display the command line to submit your app. Again, on Mac, we use mono to run the code. Windows would just execute the command directly. Notice the API key is filled out here for you. It's obscured here because it's a password. And that means don't pass out the API key to everyone. You can also select the Ruby option, which will display the command line for a Calabash submission. It has the same basic parameters here, but this is going to be submitted using a Ruby script instead of .NET and UI test. You can also do all of these steps in one pass by submitting the test through the IDE. This will walk you through the same basic wizard, but driven from the IDE itself. In addition, you won't need to obtain the API key or a command line since it's all done for you automatically. The Run in Test Cloud option is available in a context menu for the test project in Visual Studio or from the unit test pad in Xamarin Studio when you're targeting a real device. On Xamarin Studio, you can get a detailed status report on the upload through a new Test Cloud pad window as well. Now, once it finishes uploading, the IDE will open a new browser window and walk you through the options. This should remember your login if you've logged in previously, or it will prompt you to log in. And then it will begin to run the tests. Now, the tests may take a while to complete, particularly if you've selected a broad set of devices. Luckily, we do not need to stay in the browser. Once all the tests are finished, Test Cloud sends an email indicating the results summary. The email will list the overall results of the test run, indicating how many passed and how many failed. You can then log into the portal to get the full test run stats. The dashboard displays all the apps which have test results, and clicking on an app will display all of the test runs that you've performed. You can then select a specific test run to see the exact results for that run. The actual run itself will show each test in the test fixture, screenshots for each step, and the final result for each test, pass or fail. You can then drill into the failures to see which devices failed the test, see what asserts did not pass, and even examine the screenshots of what the device looked like at that moment. Now, if you're doing a broad spectrum device test, it can be helpful to filter the results to a subset of the tested devices through the Filter Devices button. This will display a sidebar, which lets you change the sorting and filtering applied to the listed devices. So you can display only failed devices if you only want to focus on that, or you can sort by device popularity or OS version to look for patterns. You can filter by form factor or by manufacturer, and this will let you understand your results much better. When you examine a specific test step, you can look at the device state at that moment, including what code was being executed, the device log, and even the CPU and memory stats on the device. In addition, when it can, Test Cloud will capture a video snippet of the test so you can play the video right here in the test result and see exactly what the app did as the test executed. Now, with all of this information, you can easily track down issues to ensure your app runs smoothly on every device and form factor out there. Now, when each test finishes, it will automatically take a screenshot of what the application looks like at the end of the test. This is disabled by default for local device runs, but it's enabled by default for Test Cloud. However, you may want to take intermediate screenshots throughout the execution of the test if your app updates things before the test is actually complete. Well, on the iApp interface, there's a screenshot method to take a screenshot, passing in a description of the screenshot. If you don't supply a name, it's just going to use the name of the test. You can then view each screenshot in Test Cloud, which is going to be identified by the description text. And this can be very useful to check visual positions of elements on different devices or see what the screen looks like at each step of your test. You should definitely sprinkle these statements throughout your tests to see progress and do a visual check on all the different devices. Now let me demonstrate uploading the Tasky Pro application up to Test Cloud. Here in Xamarin Studio, I'll use the built-in IDE integration to upload our tests. From the unit test pad, I'll right-click on our iOS tests, and we'll come down to Run in Test Cloud. This will bring up the wizard, and I'll click Upload and Run. As you can see here, it's now uploading to Test Cloud, and we get our progress indicator in the application output window. When the upload is done, the browser automatically launches and walks us through the web wizard here. So I'm going to run this on my Tasky team account, and I get to pick which devices I want to target. Let's go ahead and test this on iOS 9, for example. You see we have quite a few different choices. I'll pick, let's say, the iPhone 5S and the iPad Air. So we're going to test both a phone and a tablet. Obviously, you can choose as many devices as you would like. Here again, we can set all of those settings we talked about earlier, and I'll click Done. This now will kick off the process of running and executing our tests. Again, this can take quite a while. You might want to go back and work on the app some more. You'll get an email when this is complete. Now our tests are complete. Our test run is complete, but you can see here on our screen that for some reason, 2 of our 3 tests have failed. And this is actually good. This is what we need Test Cloud for. We need to capture these tests and find all the errors and find what's broken before we ship our application out to our customers. So let's go take a look at the results. You can see this gorgeous dashboard here telling us exactly what failed, how many failures by category we had, and interestingly, here you can see by form factor, the phone has passed, but the tablet, remember I picked an iPad Air, has not. So that gives us some information. Maybe we didn't write Tasky correctly for the iPad. Over on the left side, you can see all the results. And we're able to click on each step. Here, Tasky Pro creating a task should be successful. And you can see the first step of that task, get milk, that is okay for both the tablet and the phone. But then the next task, which is detail set, tapping save, and we can easily see here that the iPad has failed while the iPhone 5 has not. It has passed. So let's zoom in a bit. And this is where the screenshots come in very handy. You can obviously see that for some reason on the iPad, we never got to the next screen. We didn't get to the screen where we could enter the details. But we did on the iPhone. So maybe this is due to a race condition. Maybe we're not waiting long enough. But we can go back and check our code, and we can check our tests and make sure that this is actually going to work. If we want to drill into that deeper, we can click on that step, and you can see all the relevant information about it. You can even get a stack trace here. So here we have a system.exception, error while performing wait for element. where we're looking for the UI text field, it timed out. So for some reason we clicked the add button and our timeout failed. Maybe we need to increase it because this is an old iPad Air. It doesn't have all the latest processor and RAM and everything else that the newer devices have. Maybe that's why. Maybe we just need a little bit more time in our test. But then we can click on any of the other steps and see the same thing as well. And you can filter those. And here again, you can see that tapping that add button on the iPad did not transition to the next screen quick enough. But the iPhone 5S, that passed. And you can use this information to track down problems in your code, which is the main point of writing our tests and using Test Cloud to capture these types of things. Now we've seen how to use Test Cloud, how to create a test run, select devices, upload our app, and run the tests, and then evaluate the results. Thank you for watching XTC103, Deploying to Test Cloud with Xamarin University. If you have any questions, please post a question in the Xamarin University forums or schedule some office hours with a Xamarin University instructor. Thank you, and happy coding.